And I'm like you guys, I didn't charge my Chromebook. So I have very little charge. I can travel a little bit maybe. We'll see if it shuts off. Okay, so the first division problem that we're going to do is this guy right here. Okay, so this 4x to the fourth minus 5x squared plus 2x plus 4 divided by 2x minus 1. So first we're going to set it up the same way, but I want to point one thing out to you guys. When you look over here at what we did on the board, notice that there's a 0 in that spot. It's 5,201. And the 0 holds that spot because there aren't any 10s, right? There's no 10s in that number, so the 0 is there holding the spot. We have to use the same idea in our polynomials. They don't have 1 spot, 10 spot, and 100 spot, but they have terms that have different degrees. So like the first term in this polynomial has degree 4, but the next term has degree 2, and then degree 1, and then degree 0, the constant. We want it to go from the highest degree to the lowest degree without skipping any. So this one skips one, right? What term is missing? Term of degree 3. So when we set up the division problem, we're actually going to write it how you've written it before. So we're going to set it up like the 4x to the fourth thing divided by the 2x minus 1. But I'm going to put in a 0x to the third. We call this a placeholder. If you don't put that in, you would be combining terms together that don't have the same degree. So you'd be trying to add together terms that are not like terms. In your division problem that we did up on the board, it would be like trying to add something from the 100 spot with something from the 10 spot because you didn't put a placeholder into that number with for 0 tens. Is that okay with everybody? So first thing, that in the setup, if any of the things involved in our division are missing a term, then we need to put a 0 placeholder in. Okay, now it goes from degree 4 down to constant with nothing missing. What we're dividing by has degree 1 and degree 0, so those go in order. We don't have to worry about a placeholder there. Okay? Now, we're going to do the same division process you guys did. The one thing that's going to be slightly different is over there when I said, what do we do? You guys go, oh, you figure out how many times 3 goes into 5, it goes in 1 time. And it didn't matter if they didn't match exactly. Notice that we still canceled out eventually the 1,000 spot and got to move over to like the 1 spot. Like that's how the division algorithm works. So over here, we want to cancel out things that are like to the higher powers, and we want to get down to the constant. But the thing is here, you can't get close and cancel it out because they're separate terms, right? It's a little different than numbers. So we really need to make the exact same thing. So like if I want to cancel out this term that has a power of 4, I need to be able to subtract exactly the same amount, 4x to the fourth. Is that all right with everybody? So the one difference is that when we're making this first decision, it's not how many times does this go into this. It's more like, what would I multiply 2x minus 1 by so that the first thing makes exactly the same first thing here, and they would cancel out those terms. Okay? So whatever I choose is going to multiply 2x minus 1, but I'm more concerned about when it multiplies the 2x part, that what it leaves here matches exactly the 4x to the fourth. So what would I choose? What do I want so that when it comes and multiplies 2x, it will make exactly 4x to the fourth? Sammy? 2x to the third. Is that okay with everybody how I'm making that decision? So I'm deciding something here that I know is going to come multiply the 2x minus 1. But my focus is that when it multiplies this first piece, it makes exactly the first piece there. So I choose 2x cubed because 2x cubed times 2x makes 4x to the fourth. The 2x cubed also has to be distributed to the -1. So it would make negative 2x cubed. Okay? So what I write here multiplies what's here, just like it did with 3, to give me this. But I just choose this very, very wisely so that the first term always matches. Is that okay with everyone? All right, after we did this with our long division process, once we picked and multiplied and wrote down what we multiplied out, what do you do next in division? We subtract. Now, when we're subtracting something with more than one term, remember that subtraction sign distributes to each of them, okay? So here, 4x to the fourth and negative 4x to the fourth, they end up canceling out. That's exactly what we needed to happen. Then we have 0x cubed minus negative 2x cubed. So those will combine together to make it like a plus. And so those will make 2x cubed. If this does not cancel out this first term right here, then you either didn't do the subtraction correctly or you didn't choose correctly, and you should start the step over because we want it to work just like our long division process normally works, and we should go down a degree every time that we're trying to do it. Does that make sense to everybody? Okay, Hannah? Can you repeat why the reason for this? Yes, so let me rewrite this. So what you have here is once we multiplied it through, we got this. But remember, we are subtracting this. But that subtraction sign, because there's two terms, distributes to each of them. So it becomes like a negative 4x to the third, but like a positive 2x cubed. Is that okay? All right, so once we've figured out what we want, multiplied it, and then subtracted it, got the difference, what do you do next in the division process? Drop down the next term to start the process over, right? So we drop down the negative 5x squared, and we start the process all over again. Okay, so we're now making a decision. What do we want to put here so that it's going to multiply this and make this? And remember, our eyes really want to look at making that exact same first term. Okay, so I want to know what should I put here to multiply 2x to make exactly 2x cubed. Okay, Karen? Good, x squared. Is that okay with everybody? X squared times 2x makes exactly 2x cubed. Then the x squared also has to multiply the negative 1, which makes negative x squared. Once I write those down, remember, I'm going to subtract them, which means the signs change, so I'm going to distribute that negative through. So this becomes negative 2x cubed and positive x squared because I'm subtracting each of those terms. And then exactly what we wanted to happen happens for the first term. These ones cancel out, right? And then we have negative 5x squared plus x squared, which leaves negative 4x squared. And now we go through it again, right? We drop down the next term. And we go through the same process again. Somebody new, can you tell us what term we want to be next in our quotient? What would we choose next to be part of our answer? Yeah, Ethan? Good. Are you guys good with why he's choosing negative 2x? So he's asking himself, what times 2x would make negative 4x squared? And the answer to that is negative 2x. So negative 2x multiplied by 2x makes negative 4x squared, and negative 2x multiplied by negative 1 makes positive 2x. And again, we have to remember once we write those down, this is one of the most common errors, is that we're subtracting them. So distribute that negative sign to each of them before you combine them together, which would make this positive and this negative. In this case, they both cancel out, but you have more work to do in the problem. So if that's a little confusing to you, I would literally just write it as like 0x so that I could still bring down the plus 4. And it's a little bit funny, but you can still go through the whole process again. What would you multiply times 2x to get 0x? 0, okay, so I would choose 0 here. And that would make 0x plus 0. And then remember, we're changing the sign. Let's cancel out. And then we end with 4. Now, how I know to stop when I get to 4? 2 reasons. In this one, 4 is conveniently the end of the polynomial that we're dividing, so there's nothing else to bring down and stuff like that. How I know that I shouldn't try to get another term up there is by degree. I'm dividing by 2x minus 1. What degree is 2x minus 1? First degree, right? I right now have 4 here. What degree is 4? 0. Notice what I'm dividing by has a higher degree than this. It's like when you get down here and you had 2 left over, you know to stop because 2 is smaller than 3. We're looking at the same thing over here, except for we're paying more attention to degree than actual numerical value. Is that okay with everybody? So that's how I know to stop. So the answer to this problem, okay, when these two things are divided, the answer or the quotient is 2x cubed plus x squared minus 2x. You don't have to write the plus 0. You do need to write the remainder. Because we're dealing with a polynomial now and they have different degree terms, we're going to put a plus sign between here. And then we write our remainder like you would write your fractional leftovers from the problem. We have 4 left out of whatever we were dividing by, which is 2x minus 1. So this is the quotient. The quotient is just the answer to the division problem. If someone asked me what the remainder was for this division problem, it's 4. If somebody asked me, is 2x minus 1 a factor of this polynomial? what would my answer be? Is 3 a factor of 6? Yes. How do you know? It goes evenly into 6 is usually what we say, right? That means if you do 6 divided by 3, you don't have any leftovers, right? You don't have any remainder, right? So is 2x minus 1 a factor of this polynomial? No, because it did the division, but guess what? It had leftovers, which means it doesn't divide it evenly, how you guys like to say sometimes, or really it has leftovers. It doesn't have a remainder of 0. Yes, Taylor. Just like over here, how when there was 2 left over on this division problem, you would write it as this number and 2/3, 2 left out of 3 because I'm dividing by 3. So over here, 4 was the remainder. So I want to express that there's this extra little piece, but I need to show what 4 is out of, and it's out of whatever I'm dividing by. Is that okay? Is this all right with everybody? It's like this odd space of like, yes, but like no, right? Like I know the division process and this connects well to it, but it is a little bit different. So just make sure you're getting in that practice so that you guys can see those little differences and get through it, okay? All right, what we're gonna do next is we're gonna race. Are you guys excited about that? Problem, you're setting up your division problem. If I give you guys too much of a head start, he picked the easy one. What if I... You are? Yeah. You beat me.
I did synthetic division.
Oh, yeah, so did I. Okay, I'm done too. All right. James beat me. James knew my secret. What's the synthetic division? All right, so synthetic division is this. Synthetic division is a process where they found patterns and they were like, hey, instead of writing out all of this stuff, if we learn nothing about mathematicians, do they love like notation and like patterns and shortcuts and formulas, right? So they were like, if we just follow the same pattern in a division problem every time, there has to be times that we can just kind of generalize it to always work like this. So it's kind of like our completing the square. We came up with this like standard way that we could complete the square, right? Like you take the middle term, divide it by 2 and square it, and you make like the magic perfect square every time. But it only works when the lead coefficient is 1. But if you can make that happen, then every time you can complete the square that way. So synthetic division is kind of like that. If you're dividing by something whose degree is 1, meaning you can't use synthetic, here's the bad news, you can't use synthetic division all the time. If you were dividing like x squared minus 5, you would have to use long division, okay? So we have to know long division. However, for most of our purposes, synthetic division will serve us really well because most of the time we're dividing by something of degree 1. So if we're dividing by something of degree 1, we can set it up this way, okay? So how did I set this up, right? Because besides James, who beat me and put me to shame, everybody else was well on their way, but not close to being done as quick, right? So here's the first things I wrote down when I set up this problem. This was my setup. Where did those numbers come from? And James is banned from answering these questions because clearly he already knows, okay? All right, so where did these numbers come from? Jake. All right, so first set of numbers, not in the little box, I don't really know what else to call it. This set of numbers right here are the coefficients of, what's that guy called, like the dividend? I don't know if you guys remember that vocabulary, the thing getting divided. Yeah, okay, the thing inside of the division, whatever you want. Okay, so do you guys see where I got those from? 3, 9, 8, 4. Now, I didn't have to put any zeros in. Why did I not have to put any zeros in? Cooper?
There's no holes in it.
Good. Good. Okay. So there are no holes. There's third power, second power, first power constant. Okay. I would still have to use the 0 placeholders even in this division process, especially in this division process. I mean, you don't even really know what you're doing. You're just like trusting the algorithm that all this stuff works. Okay. All right. Where did this number come from? Cooper?
You're subtracting the x squared. the x plus 2, so then you have to subtract it as an item.
Yeah. All right, so what I'm doing is I'm using like the 0 of the divisor. That's what the thing that's doing the dividing, this is the thing that makes it equal to 0. And what Cooper pointed out is important to what we're going to do in the process for a minute, that we really use the opposite of it when we're putting it in there, which is important because usually in division we subtract. But if you've already changed the sign, you don't necessarily have to subtract. So we'll see that in a minute for how this kind of worked out. Okay, so is everybody good with setup? So these numbers come from coefficients right across here. And this one comes from what I'm dividing by. All right? Then what I did was the first thing I did was put this arrow and a 3. Okay? Literally meaning all I did was take the first number that was there and drop it down to below the random line that I put there. Okay? That's what I did. All right? We'll explain why we can do that in a minute. Okay? Right? So it's assuming that because 3 was the first thing here, 3 is going to be the first thing in the answer. That is true, but only true if what? Think about your long division. If you have 3x cubed plus blah, 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 and you're dividing by something and you're assuming the first part of the answer is going to have a 3 in it here, what are you assuming that you're dividing by right here? A 1x, right? So that worked for what we were doing, okay? If it was a 2x there, that wouldn't have necessarily worked. We can still do synthetic division, but we have to make a small adjustment in that case. So very much like completing the square, right? We've generalized this process, but it only works if you're dividing by something with degree 1 and it has like a 1x is what it starts with essentially. So we always have to manipulate it through that. But that's why we're allowed to drop down the first term. Is that okay with everybody? Because you can only use synthetic division if the first thing that you're dividing by right here is a 1x. That's why that works. Okay? After I dropped down the 3, here's what I got. -6. Everything that I got from here on out was done with simple arithmetic. So I either added, subtracted, multiplied, or divide things that are already up there. Does anybody have any idea where I got -6 from? Cooper?
Subtracted 2 times the 3 value.
Good. The number that ended up down here, my 3, got multiplied by this number in this little box right here. 3 times -2 makes -6. Because normally when we choose what to put on top of our division, what do we do with it? We multiply it by what we're dividing by. So that process is still kind of happening here. I get -6. Once I filled in this column, I took these two numbers, 9 and -6, and somehow made 3. How does 3 get made from 9 and -6? We add them together. Now, normally in division, we subtract. So this comes back to what Cooper said earlier. Why do you think it's okay that we're adding here instead of subtracting?
We changed it to a -2 instead of doing it as a positive 2.
Are you guys okay with that? We changed the sign of the thing that you're already multiplying by, so you don't have to subtract them anymore. Now you can just add them up because we already used the subtraction sign, so to speak. Okay? So every time we get a number down here, this number multiplies with what you're dividing by, just like you would in long division. You use that to fill in the next spot, just like you would with long division, but rather than subtracting them, you add them because you've already used the opposite. Then when you get a new number down here, when I got 3 down here, guess what I did with the 3? Multiplied it by the -2. 3 times -2 made -6. Then I took the 8 and the -6 and I added them up to get 2. As soon as I get a new number down below here, that number gets multiplied by what's in here. So -2 times 2 makes -4. I add the 4 and the -4 and I get 0. You're able to stop when you get to the last column because you know that you've set this up from highest degree down to constant. Meaning like if there wasn't a constant, like no 4 here, I would have put a 0 in that spot also to hold its place. It only works if you have all the places accounted for. Okay? So 2 things I want you to check. 1, are you okay with how I set it up? Like when you're put a division problem in front of you, do you know where to get these numbers and this number? Okay? Then the second thing is just memorizing the process. It is synthetic. It is man-made, okay? It is not like authentic. They just generalize some operations. Do you understand that you drop the first one and then every time something's down here, you multiply it times this, add up a column. Multiply it times that, add up the next column. Okay, that's the process. So we have to know the setup, we have to know the process, and then we have to understand how to read what the heck we did. Okay, this is just a bunch of numbers with some weird notation, right? Thing in a little box, line underneath it. How do I know from there that my answer is 3x squared plus 3x plus 2? So does anybody know where I'm getting the quotient from? What part of this work is the answer to the division problem? So you're looking at all this work right here. What part of this is the answer to the division problem? I see Cooper, but he's already answered a bunch for me. And I know that James knows. So how did these numbers that I got here with this work relate to the numbers that I have in my answer right here? Yeah, Taylor? Say it again. So it is a factor because there's no remainder left. That's true. But how did I know to write this as my answer? Tyler?
You get the coefficients from the second, third, and fourth.
Good. So here's the coefficients right here, right? Everything that ended up down here. And then the x, yeah, those coefficients, those, right? Coefficients of the answer, okay? That go in front of x right here. How did I know this should be x squared? It's one less than what I was dividing by because I had an x cubed thing, but I was dividing it by x to the first. So that should knock it down a power to be x squared. So what you do when you get your answer is it would always be 1 power less because synthetic division we only use with dividing by something to the first power. So because I was dividing a cubic, my answer is going to be a quadratic. So this is the x squared term, and then you just go down in powers of x. Then the next one would be x to the first. Then it would be x to the 0, which is your constant. And that last number there represents the remainder, the leftovers that you would have. And that's why this answer didn't have a little fraction at the end, because there was 0 remainder, right? It divided in evenly. It was a factor. It didn't have any leftover to write as a fraction. Okay? Is this okay with everybody? Okay? Kind of a different process. We're going to do one more kind of together because we're going to do one like what if it didn't immediately have the 1 in front that we are kind of assuming when we do synthetic division. How do we adjust that real quick? We'll walk through the process and then we'll let you guys do one on your own and just make sure you can walk through the process, okay? So when you're given one that has something in front and you want to use synthetic division, but it's missing this requirement. This is good because it's x to the first power. I can use synthetic division, but it doesn't have the lead coefficient of 1 in my divisor, the thing I'm dividing by. That's a small problem. So here's how we deal with that problem. I'm going to think of it slightly different. And so first I'm going to make sure you guys are okay with the fact that what I'm about to write is the same thing as what the problem says. Is everybody okay that this is the same thing as this? This is a division problem that means the same thing as this, okay? Now, if I don't want this lead coefficient to be 2, I can solve that problem by kind of separating the 2, just like we did when we didn't want the lead coefficient to be something different than 1 when we were completing the square. I can take that 2 out of this quantity, okay? And it would leave me with x minus a half. The problem is I still can't do a division problem without that 2 unless there was another 2 conveniently here that it could cancel out with. Does that make sense to everybody? So the reason I want to take the 2 out here is because I can't do synthetic division. But that's only useful to me if it has like a little twin factor up here that it can cancel out with. So I just make that happen. So I rewrite this forcibly taking out the 2 to leave 1 here. And then I'm going to forcibly take a 2 out of everything that was in the other one so that those 2's cancel and I don't have to worry about them. So then this looks like 2x to the 4th, 5 over 2x squared, x, and 2. And those 2 can now cancel out, and now I can just do this other division problem instead, but they're worth the same. It's like 2/4 and 1/2. Right? In 2/4, you can cancel a 2 out of each one. It's the same as 1/2. If I do 2 divided by 4 in the calculator, it's the same answer as 1 divided by 2 in the calculator. I just took out a common factor ahead of time. Okay? The numbers aren't as nice, but it will still work the same way. All right, so new people that haven't talked to us to make sure that we're in touch with kind of how to set this up. Help me with the setup. Someone, by raising their hand, tell me what number should go in this little box for this synthetic division process. Kieran. Say it louder.
1/2.
Good. Okay, so half. Is that okay with everybody? Because now I'm dividing by, x minus a half. So the 0 of that, or the opposite of the minus half that you see there, is a positive half. Okay. What should my line of values across here say, the coefficients? What would that look like for this setup? Mary? Okay, she's good. She's using the right coefficients, but we need to put one extra thing in here. Kate? Perfect, okay? Because we're missing that cubic term, and we don't want to accidentally combine together terms that are not like terms, so we need a spot for everything there, okay? So then I'm going to put my line. All right, somebody tell me the first thing I do in this process. Raise your hand and tell us louder. Taylor.
Drop down the 2.
Good. Drop down the 2. Somebody else, tell me what to do next. Good. Good. So 2 times a half gives me 1. And where does that 1 go? In the next column. Okay. And what do I do with each column? Not subtract, because we already took the opposite of the 1/2 up there, so we get to add. Okay. So 1. All right. And then we're going to continue this process. So now the 1 would multiply the half. That would be a half. I'm going to add up that column. That would be -4/2. And if you guys are okay with me, I'm going to change that to a -2 right now to make my life a little bit easier. Okay. Now this -2 is going to multiply the 1/2. -2 times a half is going to give us -1. I'm going to add up this column. 1 plus -1 is going to give me 0. Okay. Now that 0 is going to multiply the half. A half times 0 is 0. I'm going to add up this column and get 2. Okay. So I'm going to pause for a second. Anybody unsure about where something came from? So everybody's okay with the setup, what we dropped down, how we got numbers in the columns, that we added them up. Okay. All right, now we did all the work, but you can't just leave the work. The work does not answer the question. I mean, could you imagine if like an Algebra 1 student came and asked you, oh, what's this polynomial divided by this polynomial? And you're like, yeah, right here. Okay, what is that? Okay, answer the question. So what is that first polynomial divided by the second polynomial? So where do we get our answer from? Where are we going to find that? Where do I look in my work to get my answer? Where do you look? You do all this work, you got to answer the question. Where do we look? Which part of this work do I need to look at to start writing my answer? The bottom portion. Thank you. This is going to answer my question. Okay. What degree should my answer be? I had a quartic that was being divided by a linear function. Okay. Madison? The 3rd degree, right? So this is going to be, my first term is going to be cubed, which means my next term will be squared, then to the 1st power, then a constant, and then a remainder. Okay, this is still not your answer. Put it together in polynomial format. So we would have 2x to the 3rd plus x squared minus 2x. You don't need to write the 0, okay? And then the remainder is 2, so that's 2 out of what I was dividing by, which was x minus 1/2. And then you guys are going to hate this just a little bit. We don't really like to leave fractions within fractions. I know. It's like the simplifying never ends in our course. Be ready. Pre-calc is like simplifying extraordinaire half the time. So right here, this is an issue. How could we resolve that issue if I don't want there to be a half there? Connor? Okay, no, instead of adding 2, we want to multiply by 2. Is that okay? And that's okay in a fraction, but as long as when you do that to the denominator, you also have to do it to the numerator, okay? And so our final answer written in the most like considered simplified form would be to actually write a remainder of 4 with 2x minus 1. Now some of you might think like, oh, this happens every time. Like I'm always gonna have to multiply and just get back what not necessarily. It depends on what the remainder is. It depends on what you were dividing by. So you should just go through the steps every time to make sure that it's thorough and clear, okay? All right, so what I want you guys to do is go ahead and do this synthetic division problem, okay, right here. It doesn't have a coefficient in front of the x, so it should be a lot friendlier. This is just to make sure that you guys understand the process, okay? So go ahead and do that. I'm gonna walk around and pass back tests and see if you guys have any individual questions. Okay?